Question 61, function f has domain negative domain here, and it's defined by this. Okay, so a little bit like the last one, where they ask you then in the first part to show that f dash of x is always negative. They're doing that because we don't know what this graph actually looks like. Okay, we don't know what it looks like, and to show this will help us to work out the range, right? So we come to that later. So show that f dash of x is negative. So remember now you want to do the derivative of this, dy dx. That's what f dash is. So you know it's a quotient, right? That's the only way you can deal with this. It's a quotient because we've got a function on the top, function on the bottom. So let's differentiate. U and v. U is the top one, so du dx then is 2x. V is the bottom one, so dv dx then is also 2x. Okay. The quotient rule then, dy dx, or f dash of x, isn't it? Same thing, will be that times that, and that times that. So v du dx, so you get 2x times this. Take away then, of course, in the quotient rule, u dv dx, so this times this. All over, with the quotient rule, v squared. Okay. So then what you've got to do is leave the bottom as it is, because that's as simple as it can get. The top can be multiplied out though. Okay, multiply that bracket, so 2x cubed plus 10x. Do this bracket, minus 2x cubed, 2x then times 0, minus 2x times 2 is minus 6x. All over the bottom. Leave the bottom as I said. They will cancel, so you get 4x over x squared plus 5 all squared. So that's your f dash of x. And it says then show that it's always negative. Well, how are we going to do that? It all boils down to the domain of f, okay? And look at that, the domain of f is negative, okay? Domain of f is negative. In other words, x values are negative, okay? So these x values here in this function are always negative x values we're interested in. So when it comes to looking at f dash of x, 4x will be negative, won't it? Okay, will be negative because the x values are negative from the domain, so 4x will be negative. The x squared plus 5, however, will be positive. Okay, that's positive because it's a square, right? It doesn't matter what x is, you're squaring. When you square, it's always positive. So f dash of x, in effect then, is you've got a negative on the top, positive on the bottom, and that always leads to a negative answer. Okay, so f dash of x is negative. So that's saying that the gradient of this graph is negative. Okay, the gradient's always negative, and if the gradient's always negative, the curve is going to be sloping downwards. Okay, I don't know what it looks like, but it's going to be sloping down. It's always going to be sloping downwards. And what that means is, if it's always sloping downwards, it never rises at all, right? Always going downwards. What that means is, when it comes to the domain of it is minus infinity 0, okay, the lowest value in the domain here, right at the end, so to speak, of minus infinity, the lowest value will actually give you the highest value in the range. Okay, so when it comes to working out the range, okay, the lowest value will give you the lowest value in the domain. This end of the graph will give you the highest value of the graph. Okay, so it will give you the highest value of the range, and the highest value in the domain, which is 0, okay, highest value in the domain, which is 0, will give you the lowest value in the range, okay? Okay, so that's what will actually happen there when you get the range. Okay, so 0 will give you the lowest value in the range because it's a negative sloping graph, okay? So the end value in the domain will give you the lowest value in the range. That's how it sort of works. And that's going to help us then to actually determine the range, okay, of f. So if we look at the domain, minus infinity 0, so we put in minus infinity in, right, to our functions. This will be minus infinity squared plus 3 over minus infinity squared plus 5. So on the top here, minus infinity squared, well, it would be positive infinity squared then, wouldn't it? Because the minuses will disappear when you square it. Plus 3 doesn't make any difference. You get infinity squared, okay, basically. Infinity squared here, okay, on the bottom as well. Minus goes, plus 5 doesn't make any difference. And notice what you got there, you've got the same things, haven't you? Infinity squared divided by infinity squared, so that actually will lead to be 1. okay, because it's the same thing on the top divided by the same thing on the bottom. 0 then, put 0 in. Okay, and then that actually needs to be 3/5 exactly, okay? So it won't actually get to 0 on it because it doesn't include 0, so it'll tend towards 3/5. Remember what I said earlier on, the lowest value in the domain gives you the highest value in the range, okay, not included. And the highest value in the domain, 0, gives you the lowest value in the range. Okay, so there's your graph there, okay? So it's not many y values involved there, it's between 3/5 and 1, that's the range. Okay, then it says part B, right? So, you know, if you're still confused with part A, obviously watch it again, but if you still don't get it, you can still do part B, right? Still do part B, it's all about getting marks here. This question hasn't come up for a while, okay, so it could come up tomorrow. Okay, this one I anticipate coming up. It hasn't been there for a good couple of years now. So basically then, when it says to find in the inverse, you can still pick up marks here, okay? And the algebra here isn't easy, but once you get the hang of it, you will find it straightforward then. So to get the inverse, write it as y equals, okay? Of course. What I would do then is, because you want to get x equals, and you've got like the thing on the bottom here and on the top, take this up here. Okay, take this up there. I wouldn't take the y down because that's not going to help. Leave the y where it is. Just take this up here and multiply by the y. Okay, so just play around with it until you get x's on its own. So you just got to go for it sometimes to make it look a bit nicer. So take that up and multiply by y. Multiply with this bracket, so you get x squared y plus 5y equals x squared plus 3. Now the idea then is get the x's onto one side. So you got x squared y plus, no, not plus, x squared y minus x squared, isn't it? Okay, take that over, be minus x squared, and then you got 3 then, and take that 5y over, because there's no x involved here, so take that over, so it becomes minus 5y. Now on this side, notice I got x squared y minus x squared. I can't put them together, but what I can do is I can factorize, because x squared is a common factor, so take it out. X squared then times y will give me this, and x squared then times minus 1 will give me that. Okay. And then just one sort of step then to go then from here. Okay, more important step is, because you times in by this, take it over the other side. So you have x squared equals 3 minus 5y over y minus 1. Okay, and then you just got to take the square over and square root. Okay, and of course when you square root, you've got to do plus or minus. Okay, so you've got that. Then you've got to decide, is it positive or is it negative? Now, if you remember back, the domain was minus infinity to 0, wasn't it? Okay, it says in the question. So you say, look, since domain is negative, right, the x is negative, so take negative x, so let's take the negative root basically. So then f to the minus 1 of x will equal the negative of this. Okay, we're done on that. We're done on that kind of long sort of way of getting the inverse function. It does say then, to finish off, find the range and domain. Well, the range and domain is easy then, because the range will simply be the, well, let's start off with the domain, shall we? The domain will be the range of the original function, which we worked out to be 3/5 1 earlier on, and then the range will be the domain of the proper function. So we've got that there, and we completed it.